Hello everybody, welcome back to my channel. My name is Wilfred, and if you are new to this channel, kindly consider to subscribe for more, so that you can be able to get notification on the new videos. Thank you. So previously I had talked about dataset types and how to apply and which approach to apply on different type of datasets based on the nature of the data. So in the previous video, I talked about the multiple imputation, ICE, and linear interpolation. So in this video, now we are going to do hands-on Stata based on the longitudinal data that we had previously discussed in the previous video. So in this case, we are going to use the same data as you can see on my screen. I want to use the same data and apply multiple imputation, ICE, and see how to fix the missing values. So as you can see from my data, this is the data. I have 500 observations, but you can be able to see that is 1500 simply because this data set has been replicated 3 times. So like for instance, if I scroll down the ID, you can see the ID is 500. So this gives you the number of the number of maybe respondents we have in this data, or the customers, since this is a sales data. Then the another unique thing is that though I had explained on the previous video, you're able to see the ID has been replicated 3 times, each at a given point. So you can see ID1 at point 1 at time 1, ID1 at time 2, ID1 at time 3. So you're going to be able to see such kind of replications. Now, another thing you need to observe from this data, we have both continuous variables and categorical variables. So you can be able to see the gender, S levels, and we have the promotion applied, which is coded as 0 and 1. Good. Now the next step we need, so the main thing we are going to do here is I'm going to take you step by step on how to start preparing this data until we fix the missing data. As you can see, we have missing data all over, so we are going to fix that. Another thing we need to understand is that we need to understand whether our data is either missing at random, not at random, and missing completely at random. So previously I've explained this in my one of the videos. So if you want to understand clearly these 3 types of missing data, I encourage you to go on my YouTube and watch the video on types of missing dataset. It's really important. But what I can say, based on this data we have, our data is missing at random. Our data is missing at random, and this is a longitudinal data, as I've said earlier. Remember, in longitudinal studies, data is corrected repeatedly over time for the same subject. However, we often face missing values due to various reasons like non-response, dropouts, or recording errors. So in this dataset, we are tracking the sales performance. The sales performance. We have the customer satisfaction and its level as well. Yeah, within the time 1, 2, and 3. That's the data that we are going to use in this case. So let me explain something. In most cases, we have something we call clinical trials, especially on medicine field, where maybe a new drug is being tested, so as to to determine its efficiency and effectiveness on a human body. So they recruit some individuals before they they launch the drug, or they sell the drug to the market. So let us say, for instance, this clinical trial, maybe it's a 5 years clinical trial. Maybe at a given point you find out that many of the participants maybe have dropped in the second, third, fourth, fifth year. So what happens in that case if you are registered to be part of if you are registered to be part of that study, then it means that you are supposed to, maybe you are like, no one is going to be recruited until the study is over. But if you drop out on the way, then that means that your details will remain, but your subsequent responses will not be available. That is what happens. Your information will be not available. So that in that scenario, the kind of data that we are going to experience at the end of the day is actually a missing data at random, simply because the missingness depends on the observed variables but not on the missing ones. You understand? So that's the main reason as to why we categorize even this kind of data as missing at random. But for more information, go and watch that video on types of missing data. Good. So the next thing now, let us dive into the practice of this aspect. So we can start with the data exploratory. Just a few. Let us do summary statistics. So we can just say some. We have gender. It's on our data. We have gender. We have T cells. We have customer satisfaction score. We have promotional pride, and the last one, satisfaction level. Yeah, we're gonna just start with that. So I can highlight this and execute. Perfect. So as you can see, you can be able to see the summary statistic of these variables. The gender, you can be able to see the mean, the standard deviation, the minimum and maximum value. Total sales, you can be able to see the customer satisfaction, the score, you can be able to see that. Promotional pride, satisfaction level, you can be able to see. What you can identify from the observations is that the highest variable, which is gender, has 1500 observation. Since the total number of observation were 1500, or the total number of customers, they were 500, but the study was replicated 3 times, so we have 1500. So it means these other variables actually they have missing what? Missing information. So let us next check the missing values, and in this case I normally use the missing describe command, which in short is mdesk. So if I do that, now I'll be able to have now the pattern, the missingness pattern. So as you can see, we have the variable, we have the missing, we have the total, the percentage. You can be able to see the total sales. It does 305 missing variables out of 1500, Promotion applied 78 out of 1500. This customer satisfaction score 148 out of 1500. The last one 177 out of 1500. So this is the missing data pattern. Now that we have known that our data has missing data, let us move next to setting up the multiple imputation setup. Multiple imputation setup. Then now in this one we are going to use mi set mlong, and I execute this. So we have declared that data is multiple imputation. Then the next thing, this data, if you are keen, it is in wrong format. This data is in wrong format, because as you can see, like the fund book, like these cells, so this ID is repeated three times. So this data is in wrong format. So the next thing we need to do is to format it to wide format. We reshape. So we do the reshaping of the data from wrong format to wide format for imputation. So we do this before we do the imputation. So at this stage, reshape the data from long format to wide format. That's something that we need to do before we do the imputation. So, and in this I can say mi, so missing imputation. So reshape. Now what I need to reshape actually is those, remember these continuous variables. I need to concentrate on these two, these cells and the customer satisfaction score. So what I'll do, reshape these cells. These cells, we have customer, and we have the customer. Then I'll put a comma there. Then for identity, we use the ID, that's for I. J, which stands for the time, in this case J, in our case we have time. So if you have the J, maybe either being a year, whichever, so the J takes the variable which accounts for the time or the period and so on. So once I have all those, I'll just execute. I write that and execute. And I'll save. I think I've done a mistake somewhere. Let me check. Check. Shape. I'll save. Oh, sorry. I think I made a mistake here. We are reshaping this from wrong format to wide format. So at this point, I need, let me check the mistake. I need to include wide. Yeah. So mi reshape wide now from wrong to wide. So yeah, I think this one now will work. Yeah, perfect. Good. So you can see now I've done the reshaping of the data from wrong format to wide format, and you can see the output. Now the number of observation you can see is in the wrong format they were 1500. Now in the wide format, which we are going to use, it is now 500. Number of variables in wrong format they were 7, but now they are 10. The J variable, 3 values. Now the time they have been dropped, and the Xij variables. So this now the continuous variables I was telling. So the total sales and the customer satisfaction score, we can see they have been they were replicated 3 times. So it means we are going to have actually 2 more columns in each and every like 3 columns for all variables for T cells and this one for for the customer score. So you can see we are going to have CSAT1, 2, 3, T cells 1, 2, 3. So if I go back now to my data, you can see some changes here. So if you look at this data, now you can see the number of observation. If you initially when I started, there were 1500 observation here, but now you can see they are 500. And we don't have the time variable, it has been dropped. And the ID is no longer replicated 3 times, nor 2 times, and so on. You can see now the ID is single, like it's a unique variable. So like 1, 2, 3, all the way to 500. So at this point we have removed those replications. And now for the T cells, you can see this variable 1, this is the second one, this is the third one. For the other continuous variable, 1, second, third. So the other one, BS01, just remains like that because they are just like that. For the gender and the satisfaction level, they have remained the same. So we have the gender level and the satisfaction level. You can be able to see them. So this data now is in wide format. It's no longer in long format. So once we have done that, the next step is to move. So we are done with that. We are done with the reshaping of the data. So I think you have run also something on that. So next, let us move to what we call now we need to register the variables for imputation. So we register all those variables that actually were recorded using data. So we have 2 categorical variables. We have categorical variables and a continuous variable. So what I'm going to do is mi register. So mi register, then imputed. So promotion applied, that are missing data. So that's categorical. Next, satisfaction level, categorical, that's are missing values. Then now I have to include these continuous variables that we have just reshaped up here. I can just copy this, paste them here like that. Copy this, paste them there like that. Good. So these are all the variables that they reported the missing data. So we just highlight this and I execute. So you can see now I've registered those variables with missing data, and you can see 346 now marked as incomplete. So that's the first step under that. Now next I'm going to perform, so this is the most important part of this exercise or of this analysis. So remember, this is a longitudinal data, and in this longitudinal data we have both categorical data, we have continuous data. So like for categorical data, still we have those that further the level like ordinal, we have ordinal, nominal, and so on. So like in the satisfaction level where we have the medium, high, and low, so we categorize that as an ordinal data. So still there are some what you call univariate techniques or method that we are going to use to perform this multiple imputation using the appropriate models. So for instance, now to perform, let me put this, to perform multiple, let me say perform multiple imputation using appropriate models. Appropriate, let me put it like that, appropriate models. For instance, appropriate models. So model 1, let me call it model 1, is what we call Reshaping model, and we know this just for binary variable. So in this case, our binary variable we have here is the promotion applied, PA. The next model is what we call the number 2, is what we call the ordered Reshaping for binary, for ordinal. Sorry, now in this case we have for ordinal variables. So in this case, so the ordinal variables, still we have missing values here, so we have the satisfaction level as our ordinal variable. Then the last one, now we have the regression. We have regression for continuous variable. Let me put it like this so that you can be able to get. So for continuous variable. Then this case we have T-cells and the customer satisfaction level, CSAT, like that. So those are the 3 models that we are going to use in imputing this data, and I need you to be careful, because this is where you need to be careful, otherwise you may end up messing up with everything. Good. Next, I'm going to do now the imputation. We are performing the imputation. Now, missing impute. Now, chained, remember we are using the ICA, so we have to ensure we have that chained approach. So we start with Reshaping, and now this case our Reshaping variable is BA. Then the next one is the ordinary Reshaping. It's our second model, the ordinary Reshaping. And in this case, the ordinary Reshaping is S level, satisfaction level. And then next is regression. Now we can use regress for regression. And now in this case, we are regressing all of this. We have cells 1, 2, 3, customer satisfaction score, CSAT 1, 2, 3, and so on. So we copy this and then we paste it here. Now, so all this we can equal this to gender, because gender is a complete data in this case, so we can use that one. Then we add that 10 mutations, so this is a kind of 10 iterations. Then add seed. So to avoid the randomization, we can put 1, 2, 3, 4, 5, and 6, like that. So up to this point, I have captured all the required variables that we had already registered for imputation, and now I'm ready to impute the model. I'm now ready to impute the missing data to ensure that we create that kind of complete data. So what I'm going to do, I'll just highlight this, then come up here and execute. So it's supposed to run, so you'll be able to see the conditional models. So it will highlight all the models. So you have seen, we said regression, we have ordinal Rochit, and we have the Rochit model. You can be able to see them like that. So let us give it like a few minutes. It depends on actually a number of factors, like for instance the speed of your machine, maybe the storage and so on, and the iterations or the type of data. So if you have a big data, it will take even hours and so on. But you can see, since the data is not that big, we have done, it has completed it. So you can see the imputation have been done here using the chain iterations, and see the type of model, multivariate imputation, chained equations, initialization motion. So we have 10 imputations, 1 through to 10, number of imputation 10, added 10, updated 0, iterations 100, burn in 10. So you can see that's kind of basic information from that model. And now this is our main, our key thing. So you can be able to see now for the variables, promotional bride complete was 474. So for us to have 500, we had a missing of 26. So incomplete was 26, which we have imputed using multiple imputation change model to make it 500. So you can see all this has been imputed, and now we have the complete data. So another thing that you need to realize at this point, if I go back to my data, you will see that the number of observations have increased. Remember, we had redone the shaping of the data from long to wide format, and when it was in long format, we had 1500 observations. But when we reshaped this data to wide format, it turned back to 500 observation. But now we have done the imputation again, so the number of observations has increased from 500 to 3960. So these are the key changes you want to see that are appearing to our data. So if you scroll down the data, now you can be able to see it has reached up to 3960 observation. So that's the key changes you can see on that data. Now after doing that, I think we can now move to the next step. So our next step is that so we have done the imputation, we are done, our data is ready now. So if you want to perform, let us say, an analysis, now you can do, because the data is now imputed and it's ready for anything. But you cannot do that in this kind of format. Remember, the data is in wide format. For instance, if I try to just even calculate the sum of t-cells, let us say t-cells, so like I need the means and the standard deviation, it will give me an error. So you see, like there is an error, like t-cells is ambiguous abbreviations, since we have t-cells 1, 2, 3. So unless and otherwise you do what, you list them like that is and so on. But since we want to do some comparative or some sensitive analysis, which is also important thing, like we need to compare that data that we have imputed, at least to see if it is at least making sense with the original data with missing data, because sometimes you may get some values that aren't making sense at some point. We said this for reliability, this type of analysis, it will give us reliable estimates, but at some point also we need to be very careful with the type of data that we are dealing with and the values that we are getting. So by saying that, it means now I need, at this point, we need to reshape our data back. So let us reshape data back to long format again. Long format. So what I do now is reshape now wrong. So from wide to wrong, I have to mention that these cells CSAT, so we have to include those two variables there. Then for the ID, we have the ID, we have to include it back. Then J, for the time variable, we have to include our time variable again to this. So what I do is I'll be able to write that and execute. Perfect. So you can see we have now reshaped this data back again to wrong format. So you can see the what we had 500 observation, now it's 1500. Then variables, now it's 7 variable, and then now the time variable in word format we dropped it, but now it's back again, and all of these have been transformed, reshaped back to the original variables. But this doesn't mean that our data still has missing data. No. So like if now I'll go back to this, if I check the missing data, mdesk, okay, still you can see the number of the total observation we are talking here. So it's around 7,550. So from 15 already the data has been the data has been done what? The data has been imputed. So that one is where we get that. So we can do just a final summary statistic to compare what we had original in the original state and what we have right now after imputation. So summary statistics. So I can just say sum and go back and copy this exactly the way they were. Go back and copy this and I execute. Perfect. So now look at this. Initially this was the initial. So for the initial analysis, initial summary statistic, this is it. So you can be able, yeah. So initially we had around between 1300, 1200 to 1500 observations. You can see the mean, the standard deviation, and so on. But right now, after imputation, now this is the number of observation we have. Like for instance, the gender is 7,550, 25, 7,402, 7,472, 7,373. You can be able to see the mean, you can be able to see the standard deviation, the minimum value, and the maximum value. So this is evident that now this data, our data has been imputed, and now if you have any like objective, like any and now analysis that you need to do, so your analysis will be depending on this imputed data. So far so good. That is it. So and that is it. We have successfully handled the missing data in our longitudinal dataset using multiple imputation into bracket ICE in Stata. So just like a recap, so we have explored the missing data. We have used the MI impute change for multiple imputation. We have reshaped the data back to wrong format, and now we have done just summary statistic on the imputed data. Yeah. So if you found this tutorial just video helpful, don't forget to like, subscribe, and comment below. Let me know if you have any questions or suggestions for the future videos. Thank you for watching, and I see you in the next one.